Hey folks, this video is about a brand new system of measurement for angles. You have probably been used to degrees your whole math career here, at least starting in like whatever, 3rd or 4th grade. So if I have a circle here, this is 0 degrees, we can call that 0 degrees. And then if I go up here, I'd have 90, and then 180, and then 270, and then back here, I'd be at 360 degrees to go all the way around a circle, right? So, if you go with degrees, it's fine, it works, we're totally used to it. I don't know if you've ever noticed that it is based on 60, and so are our clocks, right? So, historical tidbit for you. This comes from, I believe, the Babylonians. The Babylonians needed a number that they had a lot of factors. So there weren't they didn't have to deal with decimals that much. So they chose 60. And so that's why our clocks are based on 60 minutes, 60 seconds, etc. And that's why we have 360 degrees in a circle. But when you're doing calculus and advanced physics and that kind of stuff, when you use degrees, there's all these extra factors of pi over 180 that start creeping in. And so it just looks sort of ugly. Who wants, an extra pi over 180 on every single answer that you're doing? Well, it turns out that inherent in this circle is a more beautiful, more elegant way to describe angles. And that's the way that calculus and more advanced science, that's how they describe angles. It's not with degrees, it's with something called radians. So is a radian equal to a degree? Is it the same thing? No. Like I said, a radian is built into the circle. What's the only thing that's special about a circle? Its radius. Like that's the only thing that defines a circle. So check this out here. I have a radius that's about this big, right? Now imagine that I trace, let's say that this is like a little piece of string here that I have, okay? Piece of string. And I'm now going to trace it along the circle's edge. So I'm going to take this string and I'm going to extend it along the circle's edges so that this right here is about 1 radius, right? Do you agree? Like, I'm kind of eyeballing it, but like maybe around here. Would this distance here would be the same as this distance here? Well, you just made 1 radian, okay? That's 1 radian. Now everyone's dying to know, well, how many degrees is that roughly? Like, I don't know, is it like, looks like it's about 2/3 of the way to 90, so 60-ish or so, right? You actually can figure that out because if you remember your middle school math, you know the circumference of a circle. The circumference of a circle is 2 pi times the radius, right? And that gets you all the way around a circle, right? That's 1 circumference, right? So let me just ask you again. How many radiuses does it take to go all the way around a circle? Isn't it 2 pi of those radiuses? So 2 pi, let's see, that's 2 times 3.14-ish, so that's about 6.28 radiuses, give or take, right? So about 6.28 of these will get me all the way back to the 0 mark, okay? That's a radian. So we use those all the time. We never use degrees in calculus. It's always radians. So I'm just going to start building up a chart here because I now have all I need to think about how to go from degrees to angles, okay? So let's do it here. We'll call this degrees. We'll call this radians. Right at 0, that's 0 radians, right? 0 and 0. And then we also learned, I don't know if I can fit it all in here, but I'll fit some of it in. If you have 360 degrees, that's the same as, can you still see it here? Yeah. If you have 360 degrees, that was 2 pi radians, right? 2 pi radians. And once you know that, you can just get all the other stuff by just kind of like messing with fractions. Like, here, watch. If I go halfway around the circle, say, I'm gonna put it down here for reasons you'll understand in a second. If I go halfway around the circle, so I've done a 180, right? Well, if all the way is 2 pi, guess what 180 must be? just 1 pi. Bam. And if I go 90 degrees, well, that's only half of 180, right? So guess how many radians that is? It's not pi, it'd be half of pi, right? Now, I will tell you with radians, they always describe them using fractions. I don't know why, but that's just the normal thing. If you ever said 1/2 pi, that would look weird to a mathematician. Or if you said 0.5 pi, they'd be like, I don't know, is that a radian? That's a weird way to write it. The way they always write it is using a fraction like this. So I want you to get used to that. Pi over 2. That they'll totally recognize as a radian measure, okay? And then, well, let's just keep going. If we do half of 90, isn't that 45? So guess what that would be? What's half of pi over 2? Well, if you take half of that, is pi over 4? Like that. And then I'll just tell you, the usual common things that you need to memorize for degrees to radians, like we're building here, is all of the factors of 30 degrees and all of the factors of 45 degrees, okay? So look at, we already have 45 and 90, 180 and 360. Those are a lot of the 45 factors. We don't have any of the 30s. So let's try 30. So what do you think 30 degrees is in terms of radians? Well, you can just use proportions, because check it out. Do you know what 90 is? Yeah, 90 is pi over 2, right? And how do I go from 90 to 30? Isn't this just 1/3 of 90? So this answer here should be just 1/3 of this, right? So pi over 2, and you take 1/3 of it, I'm getting pi over 6. So pi over 6. And then let's do 60 also, because that's a factor of 30. So if I try to figure out 60, how can I get that? Oh, wait a second. Wait, to go from 180 to 60, don't I have to just divide by 3? So if you do that with pi, you'd get pi over 3. And guess what? That's enough to get you started in calculus. We can go all the way around the unit circle, and we will, but we don't have to do it right now. So this is what I need memorized.